So what I want to, today's kind of a mixed bag, but it ends on a positive note from all this cancer-related gloom. But first, before we get to the good stuff, there's some other not so happy stuff. So chemotherapy. For those of you who have known someone to go through it, it's a bad word, right? No one ever, it's a miserable thing. I've not ever personally experienced it. I know people who have. It is not a pleasant thing. It's a particularly grueling therapy. And the reason, we'll talk about why that is in a little bit. But so the question is, how does it work? So I want to talk about that now. So there's drugs used to treat cancer. And there are many types. Here's a few. Talk about one that's called cyclophosphamide. I'm going to use the two examples I'm going to talk about here are ones that are used to treat lung cancer, although there are actually a variety of similar drugs for other cancers. So cyclophosphamide is one. And how does it work? It covalently attaches to DNA. That is like the benzopyrene does, which is bad news, and it damages DNA. And if there's lots of DNA damage, the cell commits suicide. That is, it's called, and it turns out that p53 is involved, and this process is called apoptosis. And as a result, the tumor stops growing. Right? So it turns out your cells have this mechanism called apoptosis, which is programmed cell suicide. It's in a variety of different parts of your body, but one of the mechanisms is this. If a cell detects that it has a huge number of mutations in its DNA, it says, I'm going to be trouble for the body if I divide. We do not want to pass this messed up DNA onto any other cells. I'm going to take one for the team. And they literally chew up their DNA to nucleotides, destroy their mitochondria, and die and burst. And that's it. So they have a program where the cell kills itself. If it's that messed up, it's built-in mechanism that says, this one cell is just going to die because it's only going to cause trouble. And that's called apoptosis. It turns out p53 is actually involved in that. So if you mutate p53, it can make it hard for cells to kill themselves when they ought to. But in any case, cells have this mechanism. Right? And so as a result, you treat the tumor with cyclophosphamide. It damages the DNA really badly. The cells go, oh, my God, my DNA is really messed up. I'm not going to try to divide. I'm committing suicide, poof, and the tumor's dead. One interesting, well, actually, questions about that, how that works. And then I want to talk about, there's a practical example of that. So it turns out that this is what happens during sunburn. And I love to be out in the sun, but it's just one of those things. It turns out that sunburn is because of ultraviolet damage to the DNA in your skin cells, leads to apoptosis of skin cells, leads to inflammation. That is the redness and pain of sunburn. So what happens during sunburn is a sort of little mini version of this. So you stand out in the sun like, classically burn your shoulders. Ultraviolet light damages DNA, damages the DNA in your skin cells. If it damages them so severely that they go, I can't divide, my DNA is way too messed up, they commit suicide. And when they burst open, they release their cell contents. And that causes an inflammatory response. Basically, your body goes, I got tissue damage here, I better go fix it. So that redness and pain is because those cells on your shoulders have actually committed suicide because you've messed up their DNA so much by being out in the sun. And the thing you might worry about when you do that, which is why sunburn is bad news, is what about that cell whose DNA was so damaged, but not quite enough to commit suicide? That means they got tons of damage. That cell's going to go on and divide, and maybe has all sorts of nasty mutations which could lead to skin cancer, for example. But it was like sort of 99% of killing itself, but it's like close enough to survive, but it's going to be really messed up anyway. So that's why sunburn is bad news for inducing skin cancer, because it's not the cells that actually die, it's the ones that maybe should have died because they're so messed up, but they're not messing up enough to actually go through apoptosis. Questions about that? Yeah. So that also explains what he asked about is, so why getting bad sunburns when you're young is worse? Because basically you're socking away all these cells with mutations in them. And maybe they haven't hit, maybe they've hit one copy of P53. Now they're just waiting around for a mutation in the other copy. So when you're younger, it just means those severely mutant survivor cells are going to be around longer. Right? If you're 80 years old and you do terrible damage to the DNA in your skin, well, you might get cancer in 20 years, but you're not going to live that 20 years. But if you get it when you're 5, you're going to be around a lot longer. Other questions? All right. So that's one kind of chemotherapy. Another kind, there's a drug called etoposide, which binds to enzyme needed for DNA replication and prevents them from working. As a result, no DNA replication. That means there's going to be no cell division. So the tumor stops growing. So both of those things, what do they have in common? They block cell division. So it makes sense that this would be a cancer treatment, right? The problem in cancer is cells dividing when they oughtn't. So if you can prevent cells from dividing, you prevent the tumor from growing. Can anybody see a problem with that? Yeah. What about the cells that aren't mutated that need to divide, right? Because there's plenty of cells in your body that need to divide, and they're not cancerous. And the trouble is, there's nothing about those drugs that says it targets cancer cells specifically. All they do is stop cells from dividing. Turns out there's lots of cells in your body that need to divide, and these will be toxic to them as well. And so the problem is, exactly what I said, is that other body cells need to divide. Other normal body cells need to divide too. And blocking them leads to side effects. Things like nausea, hair loss, and anemia. So one of the many unpleasant side effects from chemotherapy is nausea. Why is that? Because the cells which line your stomach are constantly being basically digested by your stomach. They need to be replenished. Those cells need to divide. If you inhibit dividing cells, you're not replenishing your stomach lining as you ought. And as a result, you get these nasty toxic side effects. You get nausea and troubles with digestion because you're not fixing your stomach lining. I'm not sure quite why your hair falls out. Presumably the cells in your hair follicles need to divide rapidly in order to produce hair. And so as a result, they're poisoned by chemotherapy, and that's why people oftentimes lose their hair. You get anemia because your red blood cells and your white blood cells need to be produced by mitosis all the time, because the red blood cells last about a month before they need to get replenished. And so you're inhibiting that, so you have not enough red blood cells. And there's a whole host of other nasty symptoms from chemotherapy as a result of inhibiting the normal cells. And here, if you think about it, the therapeutic window is really small. The difference between the disease, cells in your body dividing too fast, and the normal thing, cells in your body dividing, is not a lot. It's not a bacterium, it's your own cells. It's a very tiny difference between those. And so finding a drug that can split that difference is quite difficult. Questions about that? So this is why current chemotherapy is so unpleasant. Although I want to talk about some new